Okay, level 4. What you're going to notice about level 4 is that there is no drawing. Of course, what that means is you have to make your own drawing. In fact, that's one of those things I want you to get used to, is a lot of times you get word problems and nobody draws you anything. So you're going to have to do your own. When you do your own drawing, the better you make it, the easier it will be for you to solve it. So it says to construct an equilateral triangle with S equals 8 inches. So of course I'm constructing, so I'm going to do one 8-inch segment, and then I'm going to do the equilateral triangle construction. So this is 8 inches. The equilateral triangle construction, I'm sure you remember, I'm not going to go too slowly on this. We use the compass, put the compass out to the width of that original segment. We get two congruent arcs that are both 8 inches. And then we finish our construction of the triangle. Now this may not seem like that hard of a problem really, because all it is a triangle inside of a circle. There are some things about this that will just give you so much trouble. It'll mess with your head. Okay, so this is my equilateral triangle. So let's just get some facts. What will be the measure of each of these angles? Angles. 60. 60 degrees, 60 degrees, 60 degrees. How long would every side be? 8 inches, right? Okay. Now we've got this issue that we want to make a circle that goes around the triangle, intersecting the 3 vertices. In other words, it has to touch all 3 of these. So where do you think the center of the circle has to be?
In the middle.
In the middle of the triangle. So how do we know where to put it?
Make a dot.
You just make a dot and just guess?
Figure out the height and just do half the height.
The height and half the height?
Figure out the height and then just...
It's a nice idea, but it's actually not accurate. Does anybody have any other idea? Okay. Here's an idea. What if we divide this exactly in half and make a mark at 4 inches? Do the same thing on the other segments. Make marks exactly halfway across. How are those marks? What are those marks good for?
Oh, you can make
How will they help us find the center?
You can make a second
what's it
Jerry sees that we can make another triangle in there, but is that going to help us find that?
No.
We can make another triangle inside there, and eventually we'd end up with a tiny triangle exactly in the middle. Is that a good idea?
Oh.
That would be really slow. There's another thing that will work better. Watch this. If I go from the vertex to the midpoint of the opposite side, on all 3 sides, where will these 3 segments intersect?
in the middle?
Somehow in the
Exactly in the center.
I knew that.
Everybody see that? Okay, things that are worth noticing. If this was 60 degrees, what is each of these 2 angles going to be? 30. So this is 30 and 30. Is this 90 right here? It is, isn't it? So this is 30 and this is 90, then this has to be 60. Does that make sense? So 30, 60, and 90. Like we remember, this is half of an equilateral triangle. Are you guys getting what I'm saying? This is half of an equilateral triangle. So the equilateral triangle that it comes out of would be like this. But in this case, what we know is this distance. What is this distance? 4. So it would be the height is 4. You guys get what I'm saying here? What do we want to know? We want to know the radius for our circle. Okay? So if we want to know that, and we're looking at this triangle, then the radius is going to be this. So we'll call that x. And like we said, let's get a better marker. The height is 4. This is x. If this is half of an equilateral triangle, then this has to be x divided by 2. So we're going to do the Pythagorean Theorem with this.
Okay.
So what's a here?
2? No, 8. Wait, what?
Which one's a? Come on, that's the easy part. So say it.
One on the bottom. Can't remember what it's called.
Do you guys know how to say this?
Denominator?
X over 2. That's what you're supposed to say.
Oh.
Which one's B?
I mean,
4.
4. Which one's C?
X.
X. Okay, so we have x over 2 squared plus 4 squared equals x squared. This is weird because we have x on both sides, so this is going to mess with you a little bit. What is x times x?
X squared.
X squared. What is 2 times 2?
4.
4. So x squared over 4 plus 16 equals x squared. You guys get this?
Yeah.
Okay, I have to get this out of here. So I've got to subtract x squared over 4. So that means I have to do minus x squared over 4. That crosses out. I'm left with 16 equals x squared minus x squared over 4. In order to subtract fractions, I have to have the same denominator. So I'm going to multiply by 4 here and by 4 here. So what's 4 minus 1? 3. So 16 equals 3x squared over 4. You guys still with me?
Yeah.
Okay, so 16 is 3/4 of x squared. So what we'll do is we'll multiply by 4, we'll divide by 3 to get our answer. So 16 times 4 is 64. So x squared equals 64 over 3. What I did is I multiplied by 4 and I divided by 3. So if I take the square root of this, x equals 8 over the square root of 3. What's the square root of 64? 8. Square root of 3. So it's 8 over the square root of 3. So that's x. That's the radius of my circle. So this is a really challenging problem because it involves lots of math. So anyway, I found my radius. I'm going to do my circle. What I got to do is get this and trace around.
That's a crooked circle.
That's a pretty crooked circle. I'm sorry it wasn't better. Yeah, the issue is that this compass really has trouble with small arcs. But here's my circle. Okay? I'm trying to figure out this area. So what I have to do is I have to figure out the area of my circle. So if x, or the radius, is 8 over the square root of 3, then what I've got to do is square that. So the area of the circle is going to be pi times the radius squared. Well, I have 8 over the square root of 3. So when I square that, it's going to be 64 over 3 pi. That will be the area of the circle. Because it's 8 squared over the square root of 3 squared. So there's the area of the circle. 64 over 3 pi units squared. The area of the triangle, pretty simple. You take the 8. 8 divided by 2 is 4. 4 squared is 16, so it's 16 square root of 3 units squared. The perimeter of the triangle, 8 plus 8 plus 8 is 24. In fact, it's not units, it's inches. And the circumference of the circle is going to be 2 pi times r, so it's going to be 16 over square root, 16 over the square root of 3 inches, pi inches. Yeah, so clearly even I have some trouble balancing all this stuff. But anyway, the shaded area is the circle area minus the triangle area. So we get the most beautiful thing ever. 64 over 3 pi minus 16 square root of 3 in parentheses inches squared. So was that hard or really hard?
Really hard.
Really hard and insane. But hey, if you guys can understand all that, you're doing great. Even if you can't